Assalamu alaikum. Welcome, dear students, to a new unit, Unit 4 Mechanics, with the first chapter in this unit, Chapter 12, Mechanical Actions, Part 1. Let's prepare our notebook, pen and rulers, and a calculator. Please, before you start, sit in a quiet place, prepare all the materials you need, follow the teacher's instruction, write notes, write your answers, pause the video and memorize. Repeat the video whenever needed and don't forget to communicate with your teacher for more clarification. By the end of this video, you will be able to define a force, indicate the SI unit of a force, determine the intensity of a force using a dynamometer according to its scale, represent a force by a vector. Let's start with our first objective by watching the following video. What is a force? The boy in the video is holding a magnet, which in turn attracts the other magnets. This boy pushes the wooden sled on the snow. This girl pulls the box. What about these children? What are they doing? They are pulling a rope. What about this girl? She is pressing on the snow and pushing it to build a snowman. Actually, all these actions, pushing, pulling, holding, pressing, attracting, are actions exerted by one object on another. Actually, we can define a force, push or pull, as a mechanical action exerted by one object on another. But in the previous year, we have learned that forces are not able to be seen. So, how can we know that they exist? We know that they exist by their effects. So what are the effects of a force? Let's watch. A force may set an object in motion. For example, this ball is at rest, and the force exerted by the player on the ball set the ball in motion. Also, a force may modify the motion of an object, either by changing its speed, or changing its direction, or stopping the motion. Observe the force exerted by the goalkeeper on the ball. This force changes the direction of motion of ball. Another effect of a force is to deform the shape of the object. Let us observe the following video. The player is pressing on the ball, and the effect of this force is to deform the shape of the ball. Let's practice by performing the following application. We will present some GIF animations. Each time you need to indicate the object exerting the force, the object receiving the force, and the effect of this force. In the first animation, we have a wooden machine that squeezes a ball. Which object exerts the force? Yes, that's true. It is the wooden machine, and it is exerting the force on the ball. The effect of this force, as you can see, is to deform the shape of the ball. Another example, the boy in this case throws the ball which was at rest. Then the object exerting the force is the boy, and the object receiving the force is the ball, and the effect of this force is to set the ball in motion since it was at rest in the boy's hand. Here the player reverses the direction of the ball, then the object exerting the force is, yes, it is the player, and the object receiving it is the ball, and the effect of this force is to change the direction of the motion of the ball. Now we can raise the following question to ourselves. How can we distinguish between two different forces having the same effect? The answer is, forces are distinguished by their characteristics. So, what characterizes a force? Before the video starts, please, while watching the video, take some notes on your notebook.
It's holiday season, and many people are going on vacation. The airport is full of travelers trying to catch their flight. Most people use a trolley to carry their heavy baggage. To move the trolley, a force has to be applied on the trolley. A force is a vector quantity which has both magnitude and direction. The magnitude of a force indicates how strong the force is. For example, this man is pushing a trolley with many large bags on it, while this boy is pushing an empty trolley. The man needs to apply a stronger force in order to move his trolley. In other words, the magnitude of the force applied by the man is greater than the magnitude of the force applied by the boy. The direction of the force indicates where the force is pushing or pulling an object towards. For example, this man applies a force directed upwards on the suitcase to lift it up from the ground. Once the suitcase is placed in the trolley, the man then applies a force directed towards the front, and the trolley moves forward. For a force, the point of application is the location where the force is applied. For the force applied by the man pushing the trolley, the point of application is on the handles of the trolley. This man is about to miss his flight. He better increase the magnitude of the force he is applying to the trolley and get to his gate quickly.
Let's now list together the characteristic elements of a force. Forces are characterized by their point of application, which is the point where the force is applied. Also, they are characterized by their line of action, which is the line along which the force is acting. This line could be either a vertical line, or a horizontal line, or an oblique line making a certain angle with either the vertical or the horizontal. Also, forces are characterized by their direction, which is the sense of the force. The different directions could be either upward or downward in the case where the line of action is a vertical line, right or left if the line of action is a horizontal line, upward to the left or downward to the right, upward to the right or downward to the left in the case where the line of action is an oblique line. And the fourth characteristic is the magnitude of the force, which is the intensity of the force. The magnitude of the force is actually a numerical value which tells us about the strength of this force. Then we need to use an instrument to measure the magnitude of a force, and we need to express it using a certain SI unit. Then the magnitude F of the force vector F vector is measured using a spring balance or dynamometer. This is the spring balance or dynamometer that you have seen in the previous year. You can notice that we have named the force vector by a certain letter, which tells us about the name of this vector, and with the symbol of the vector on its top. Then each force vector should be named in this way. And when talking or expressing the magnitude of this vector, we use the same symbol, but without putting this or the symbol of the vector on its top. The magnitude of a force is expressed in a Newton, denoted by capital N in the SI unit. Notice that if the dynamometer carries a scale, like this dynamometer, it carries a scale times 10. This is the indication of the dynamometer, which is approximately 3.5. And this is the scale carried by this dynamometer. In this case, the magnitude of the force is equal to the indication times the scale. Then, the magnitude of the force measured by this dynamometer, in this case, is equal to 3.5 multiplied by 10, which gives us 35 Newton. As we have heard in the previous slides, forces are represented by vectors. But why? Since vectors allows us to indicate or determine all the characteristics of a force. How? The beginning of the vector tells us about the point of application of the force. The line holding the vector tells us about the line of action of this force. The head of the vector tells us or indicates for us the direction of the force, and the length of the vector from its beginning till the top of its head, measured using a ruler, indicates for us or allows us to calculate the magnitude of a force. Let's practice now by performing the following applications. The boy in the figure pushed the ball with his head by a force L vector represented to a scale. Each 1 centimeter corresponds to 15 Newton. You are asked to specify the characteristics of L vector. Before I start telling you about the way of solving this application, please pause the video and try to solve it by yourself to test whether you have understood the previous information or not. Since we are asked to characterize the force vector L vector, we will start with the first characteristic, which is the point of application, which is the point where the force is applied. And as we have mentioned in the previous slide, it is indicated by the beginning of the vector L vector. Then it is point E. The second characteristic is the direction of the force, which is indicated by the head of the vector. As you can see, it is upward to the right. The third characteristic is the line of action, which is indicated by the line holding the vector. In our case, it is an oblique line, making an angle 25 degrees with the horizontal or 65 degrees with the vertical. The fourth and the last characteristic is the magnitude. Since the name of the force is L vector, then the magnitude is L without vector. As we have mentioned in the previous slide, the magnitude of the force is indicated by measuring the length of this vector. Then you need to use a ruler. Using a ruler, we will measure the length of the vector from its beginning or from the point of application till the head of the vector. You can read 3.2 centimeter. I will denote this value by x. X represents the measure of the length of the vector L vector. It is 3.2 centimeter. After measuring the length of this vector, how can we calculate the magnitude of this force? Here we need to use the given scale, which is each 1 centimeter corresponds to 15 Newton. Place the length of the vector expressed in centimeter under 1 centimeter, and you need to know 3.2 centimeter corresponds to how many newtons, which is the magnitude of the force vector L vector. Here you need to apply the cross multiplication rule such that L, which is the magnitude of the force vector L vector, is equal to 15 multiplied by 3.2 and divided by 1, which gives us 48. And don't forget to write the unit of the force, which is in Newton. Let's move now to our second application. In this application, you are asked to represent by a vector a force F1 vector applied at point O, directed upward to the left, making an angle 35 degrees with the horizontal, and having a magnitude F1 equal to 21 Newton. Keep in your mind that whenever you are asked to represent a force by a vector, you need to start with listing clearly the characteristics of this force. From the given, the force F1 is characterized by its point of application, which is the point O. This is the point where we are going to start drawing the vector from it. Also, the direction is upward to the left. Then, focusing on this figure, since the direction is upward to the left, then we are going to draw the force vector in this quadrant. We will stress our work on this quadrant. Since the direction is upward to the left, then the line of action is an oblique line. Actually, this line is making an angle 35 degrees with the horizontal. To draw an oblique line making an angle 35 degrees with the horizontal, you need to use a protractor. Since the angle is given with the horizontal line, then you are going to place the protractor on the horizontal line in this way, and read on it 35 degree, 10, 20, 30, and this is the 35 degree, and mark this point. Then remove the protractor. Our third characteristic is the magnitude, which is 21 Newton. We still need to know the measure of the length of this vector in order for us to be able to draw it. You need to start by choosing a convenient or appropriate scale. In our case, I will use the following scale, which is each 1 centimeter corresponds to 7 Newton. Now I need to calculate the measure of the length of this vector. Since each 1 centimeter corresponds to 7 Newton, what is the measure of the length of the vector which corresponds to 21 Newton, which is the magnitude of this force? Applying the cross multiplication rule gives us that the measure of the length of this vector is x equal 21 times 1 divided by 7, which gives us 3 centimeter. Now, holding a ruler, we can measure the length of the vector to be 3 centimeter. This is the 3 centimeter. I will draw the vector till this point. Now, you need to take care to write the name of this vector, which is F1 vector beside the vector itself, and don't forget to put the head of the vector, since the force is a vector quantity and it is represented by a vector, not a segment. Now let's summarize the ideas of this video. In this video, we have learned that forces are mechanical actions exerted by an object on another. They have different effects, which are to set an object in motion, to modify the motion of an object, or to deform an object. Also, they are measured using a spring balance or dynamometer. Forces are characterized by their point of application, their line of action, their direction, and their magnitude. This is the end of part 1. Thanks for your attention.